Hello, this is question 3 from paper 2 from the 2020 higher level Leaving Cert maths exams. Up the top right corner of the screen you'll find a card that will bring you to the playlist that has all the solutions to the questions in this paper, and below the video you'll find a link to the image of this question so you can try it in your own time before looking at my solution. This question is split up into two parts, completely separate, so we're just looking at part A here. It gives us a diagram like this. I'll leave off the letters, they're not too important. It's a picture of a flagpole starting here. I'll draw a little flag there. This is a flagpole. This is the ground. So we're on a hill sort of, and we can stand here and measure this angle. I guess we'd have to measure the angle to the horizontal because of gravity. That's not important, but if we were able to measure the ground basically, and that's 5 degrees. And using that and a sextant of some sort, we could measure this angle in real life at least, but they've just given us this number here, 35. What else have they given us? A 52. We could get a measuring tape and measure this length from here to here is 6 meters. But maybe there's a fence here and we can't measure this distance to the flagpole. Maybe it's in someone else's property, I don't know. So it could be a real life question. Maybe there's a river in the way. Not on a slope there wouldn't, but anyway, we don't know what that length is. That's what the question asks. They ask us what is the length from here to here. So we'll put that in as an X. Although I think I'm going to use the other letter, so I'll just have to call that Y. Now the first thing I like to do in a question like this with triangles, write in everything I know. This is everything they've given me, I believe. Yes, this is everything they've given me. Write in everything else. You can figure it out. If I give this picture to a primary level student, a primary school student, they would be able to fill in some numbers, I think. They'd see a triangle, 5 degrees, 90 degrees. Well, then this angle must be 85. They'd see a straight line, and here's 52 on one side. Well, the other side must be 180 minus 52, which I believe is 128. Now they'd see a triangle with two angles, 35, 128. We add them together, we get 163. That means this angle up here must be 17. Again, we have 85 on a straight line, 85. This side must be 95. We have two angles, add them together, we get 147, which leaves 33 degrees here. Maybe there's more, but that's everything I see. I think that's all the angles, in fact. So that's the first thing I would do in this question. You would need to do it at some point. You don't need all the numbers I've just got here. For example, I'm not sure we'll ever use 17. No, we will use 17. Maybe 95? No, I think I'll use that as well. I'm not sure. I don't think we need all these angles. But that's the first thing I would do. Fill in everything I need to know. Now I'd look at some sort of path to get me this answer for X. How I do that is I think of a triangle as having 6 things. Triangle has a side, a side, a side, an angle, an angle, an angle. 6 things. And we've learned over the years that you need to know 3 of these things to find out everything. Except, with one exception, if we know 3 angles, that's not enough. Because this triangle would be identical to this bigger triangle, even if the angles are the same. So 3 angles isn't enough to tell me about something. So that's it. I'll look at all these triangles here and see if there's something I can figure out. Do I know 3 things about any of them to find out everything else? Angle, 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 that one's useless to me. Angle, 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 useless to me. This triangle up here. I know an angle, a length, angle, and an angle. I know 4 things, more than enough. That means I can figure out what this length is, and I can figure out what that length is. We can do that work. And we're nearly finished then, because here's another triangle. We have angle, 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 but now we will have a length. That means I can figure out everything. I figure out this length and the X we need. We can figure out that length. So that's it. I've set the plan out. All I have to do is do it now. We'll have to look at 2 triangles. This triangle here, 35, doesn't look the same, apologies. 35, 128, 17, and this is 6. I need this length here. Let's call it Y. Let's find out what Y is. It's a non-right angle triangle, so that means we should use the sine rule or the cosine rule. Sine rule is easier in my opinion, so I'll try and use that. Y divided by its opposite angle, or sine of its opposite angle, 35, is equal to any of the other sides. We'll take 6 here, divided by its angle, sine 17. And then we can just rearrange this so we get y on its own. Y is equal to 6 multiplied by sine 35 divided by sine 17. And I'll keep this as an answer. You could put this in a calculator and get your answer. I like to keep it like this. I don't like to do work with rounded off answers midway through a question. It wouldn't matter in this question because the only thing we're going to do with this number is multiply or divide it, which won't change how accurate it is. But if you were to square it or square root it or get sine or the cosine of it, it could change it significantly from your final answer. If you are going to put it into decimal places, I recommend use much more than they ask for. They ask for 2 decimal places at the end. In the middle of your question, use 3 or 4, just to be safe. Or even better, use the exact answer. That's what this is. Okay, so that's this triangle solved. We found this length. We found this length. Let's do the next triangle. So this one is 95, 52, 33, and this side here is y. And that's what y is. We know exactly what that is. Here's x. Let's use the sine rule again. I believe it'll work. X divided by sine 33, that's this angle here, will be equal to y. Let's use the real number for y. 6 sine 35 divided by sine 17. Then divide that by sine 95. Well, divide is the same as multiply by a fraction. I'm just doing it this way to make it look prettier. You could just divide under here if you want. I just find it gets confusing then. How does things interact with which things? Instead of dividing, I often multiply by a fraction. It's identical. It's the same thing. Okay, we need to rearrange this. You know what? Because I'm on a whiteboard, it's much easier for me to do this. I'll just move this sine 33 over here. Sine 33. This we would need to put into a calculator. Let me double check my notes, see if I got all the same numbers here. 6 sine 35, sine 33, 17 and 95. Yeah, when I put that into a calculator, I got 6.44. That's to 2 decimal places. Okay. Now, some of this could be wrong, so check my work, see if you got the same answer. Put in the comments below if you did, if you didn't. Let's see if we can find a mistake. But that's it. It was all about the start of this question. It was all about doing the easy work. This was getting you marks. This was getting you lots of marks. And then it was just 2 sine rule questions. So a really straightforward one, but lots of students would have got lost on how to do these simple things. They would have said, oh, I can't use sine rule. I can't use cosine rule. You could if you noticed some of these angles. And as I said, a primary school student would have been able to find a lot of these. Although when you get older, you forget a lot of that stuff. You forget to look for the easy things. All right, I will rub this out and we'll do part B. Okay, part B is a really interesting question because it doesn't give us nearly any numbers whatsoever. It gives us a drawing of a large circle, a smaller circle that's a tangent to it, internally a tangent to it, and then from the center of this circle, it hits the other circle. My drawing is not the best. This is a tangent, this is a tangent, and it should be a little more narrower than that. Still, that should be good enough for us. Let's put in the center of this circle as well. Gives us some letters. We're not going to need them. And it wants us to find the ratio of the area of this big circle. Let's write the area of the big circle. Pi. I'll use big R for the ratio, the radius of the big circle. Pi big R squared. And the smaller circle would be pi little r squared. And the ratio between two things is like dividing. So the pi's cancel. And they tell us this is equal to k the ratio to 1, which is just like saying dividing is equal to k. The ratio between these two is k. Okay, so I guess that's the first bit they want you to notice. They give you lots of marks for this. R squared divided by r squared is equal to k. That's what they want you to find. What is r though? That's really the difficulty. To start this question, you need to notice one thing, at least one thing. There's a few little tricks in this. And that is that a circle inside two lines like this, inside a triangle if you want, but really just importantly inside the two lines, cuts this angle, cuts it perfectly. So they tell us this big angle here is 60 degrees. That means this must be 30 and that must be 30. It's the first thing they want us to be able to point out. Again, there'll be lots of marks for that. They give us that this is a right angle. That was generous because they didn't have to, I don't think. That's going to be important to us as well. Let's draw that little triangle there because that's where we're going to get the next answer from really. This is 30. This is a right angle. We've no lengths though. Okay. Oh, we do. Sorry, we've one length here. This is the radius. This one here is the radius. That's one hint I can give you about questions involving circles. It's nearly always about the radiuses, and people forget to write them in. Look at a picture, write everywhere you can there's a radius. For example, from here to here is little or. From here to here is little or. From here to here is little or. Most of them aren't going to be important to us, but they're there. Big or, from here to here, here to here, and here to here. They're all big or. Some of them are actually going to be quite important to us. I want to write in another length on this triangle. That's what I need. I need another length over here. I can use numbers and I can use the letter or, a little or big or. I want to know the length of this or this. So that's the next leap of insight here. What is the length from here or here? This one is the one we're going to be able to get. So I'd like you, if you can't see it, pause it, think about it. I'm going to be able to write some letters here that tells me the length of this part of the triangle. So I'll let you pause in your own time, but I'm just going to give you the solution in a moment. So the length here, the real secret to notice here is that this length is little or, and let's use a different color here to help a little bit. The length from here all the way down to here is big or. So that means this length in between is big or minus little or. So that's going to be enough for us to solve this question. Now, that was the second real leap they needed you to know. They need you to notice that's 30 degrees and 30 degrees, and they need you to notice this. So now we have a right angle triangle. We can say sine of 30 degrees is equal to or divided by or minus or. Now, sine 30 degrees, we put into a calculator, it's just a half. It's one of the more famous ones. A half is equal to or divided by or minus or. Rearrange this a little bit, we'll get or minus or is equal to 2 or. We'll get big or is equal to 3 little ors. So I think this would have been unfortunate, but some students might have got here and said, oh, the ratio is 3 then. The ratio from the big circle to the little circle is 3. They didn't ask for the ratio of the radiuses though. They wanted the ratio of the areas. So that's up here. So we need squared here. Just square both sides. We'll get or squared is, big or squared is equal to 9 little or squared. That's the ratio there. This divided by this guy, big or squared divided by little or squared is equal to 9. That's what k is. The ratio between the large circle and the small circle is 9. And if you look at the picture, looks about right. That's not always going to be good enough in maths to check your answer with. But sometimes it helps. If you got a ratio of 2, you look at the picture and go, oh, that doesn't look good. And if you got a ratio of 1,000,000, oh, that doesn't look good. So check your work in any way you can. In this case, 9 looks about okay. So I'm happy enough that that's probably the correct answer. All right. Hopefully you are as well that I've done it now. But if you get a different answer, if you see any mistakes in my work, let me know and put them in the comments below. I'll do my best to get back to you. And thanks for watching and have a great day.